Okay, this is lesson 8 of module 6, and in this lesson we're going to look at how to fit a line to a scatter plot. So we've been analyzing patterns in scatter plots in the last couple lessons, and so we're just going to add a little bit of precision to that. A line in a scatter plot is going to help us to make predictions, and so in Math 8, you are going to do this in an informal way. In later math classes, you'll do it in a more precise mathematical way. Okay, so our first example is housing costs. And here's some data from the Midwest. And it tries to look at the correlation between the size in square feet of a house and the price of the house in dollars. So looking at this table, we can kind of begin to see a correlation. I can pick out some small houses here and look at their price, and then pick out some larger houses and look at price. But we can't really tell a lot until we do a little bit more with the data. Okay, so the scatter plot's going to give us a good picture of the data. So we can ask ourselves those questions that we talked about in the previous lessons. Does there appear to be a relationship between the two variables? Is there a relationship between the size of a house in square footage and the price of the house? And we could say, yeah, there appears to be a positive linear trend. We can see it kind of rising up right here. So it's a positive linear trend because as the size of the house increases, so does the price. And that kind of is reasonable there, and maybe something, even though you've probably never shopped for a house, something that you kind of know to be true. Okay, so we're going to refer back to this scatter plot and the data itself for the next several exercises here that we'll work through together. So what can you tell about the price of large homes compared to the price of small homes table? And we could say something like large homes cost more than smaller homes. Okay, but let's look back at the data table and notice that this house here that we pointed out, 991 square feet, was 150,000, and we can find another home that's 150,000 that's almost twice as big. So here's a house, and this one's 956, and it's only 60,000, 59,900. So there's variation within this data. So there's probably something pretty fancy about this house. Maybe it has a pool, it's very updated. So there's variation, but in general, based on the scatter plot, we can see this upward trend. Okay, and there's that really kind of, no, that's not the expensive one. But so anyway, there's some variation in the data, obviously. But larger homes tend to cost more than smaller homes. So use the scatter plot to answer the following questions. Does the scatter plot seem to support the statement that larger houses tend to cost more? Yeah, it did, and we just talked about that. We can see this general upward trend in the points on our data plot. It's a positive linear trend in the data. And so we could say something like the positive linear trend, positive linear trend means this: the larger the house, the greater the price. Generally, the greater the price. Okay, so what is the cost of the most expensive house? And I think we want to go back to the data table for that. So the most expensive house, the only one that has 7 figures in it, goes up to the next decimal place, is this one here, the 5,232 square foot home for $1,050,000. Okay, the cost is $1,050,000. And where is that point on the scatter plot? Well, it's at, let's find it. It's this one way up here, right? In the upper right-hand corner. The upper right-hand corner. It's kind of an outlier a little bit, although it has a few partners over there. But there's not very many in that category. Okay, now let's spend a little bit of time discussing this next question, part C. Some people might consider a given amount of money and then predict what size house they could buy. Others might consider what size house they want and then predict how much it would cost. How would you use the above scatter plot? Okay, so this question is getting at which variable do I want to choose the value of? And so I either want to choose the money and then predict the size, or choose the size and then predict how much it would cost. So let's look at the scatter plot here. So this is getting at something, some terminology that you may or may not have had a lot of exposure to, but the variable that we put on the horizontal axis we refer to as the independent variable, because which is why we put it there. So it's the first coordinate in the XY pair, and the horizontal is the first coordinate, and then the vertical would be the second. This is the independent variable. It's the thing that we choose, and then this depends on the dependent variable, depends on our choice of independent variable. So the way this scatter plot is graphed, it's assuming that people want to choose the size house. You know, I want a 4,000 square foot house. I wonder how much that's going to cost me, and come over here. Or I want a 2,000 square foot house. I should expect to pay this amount, the $200,000. So that's not to say that you couldn't use this graph by choosing the price and then predicting the size. Of course you could, but kind of the more comfortable way to use a graph like this is that this is the independent. It's the thing you choose, independent variable. Whereas this would be, let's get rid of this here. This over here would be the dependent variable. Whoops. Dependent variable. And so you always want to, when you're making one of these plots, you have to think in terms of which is the variable that I want to choose the value of, and then figure out or predict from the plot what the dependent variable would be. So here we're going to say price depends on the size of a house. And that means it's the dependent variable. Okay, so just to kind of restate, we're going to use size and predict price. Okay, so our next question asked us to estimate the cost of a 3,000 square foot home. Okay, so I'm going to come over here. I'm going to pick 3,000 square feet and then think about, well, how much would it be? Well, I know it would be in here somewhere. So write a prediction for what you think a 3,000 square foot home would cost, and record that on part D. Okay, if we were all together, I would probably have you share what numbers you got here. So let's see. Somebody might say 400,000 would be an estimate, maybe 500,000. Probably not less than 300,000, maybe not more than 6, but somewhere in there would be a reasonable estimate there. So part E asks us, do you think a line would provide a reasonable way to describe how price and size are related? How could you use a line to predict the price of a house if you're given its size? So let's look back here. So I think we would all agree that a line, this appears to be a positive linear trend, and a line would maybe be a good way to make these predictions. Okay, so exercise 3 asks you to draw a line in the plot that you think would fit the trend in the data. And then we're going to use your line to answer the following questions. Predict the price of a 3,000 square foot home and a 1,500 square foot home. This would be most valuable if we could compare our answers with others, but we're going to go ahead and work on this ourselves. So go ahead and draw a line that you think best fits that data. So pause the video and do that. Okay, now that you've drawn your line, I'm going to just draw an example of maybe what a student might draw. Right there, I'm going to draw my line. Yours could be different than that. That's okay. We're going to compare our numbers. So you're supposed to use your line to predict what a 3,000 square foot house would cost. So I'm going to use my line to do that, and you should do it with yours. So I'm going to follow it up here and then follow it over. And it looks like it is halfway between the 4 and the 600. So I'm going to go with my line is predicting the 3, whoops. I'm on the wrong question. My prediction for 3,000 would be $500,000. And let's go back and see my prediction for a 1,500 square foot home. So that would be $1,100, $1,200. Well, it's halfway in here. Okay, so there's my 1,500 square foot home, and it looks like it's under 200,000. Would be maybe 180,000. Now it's likely that you got different predictions from what I got, and that's fine. Hopefully they're somewhere in range. But we use kind of a ballpark method for fitting a line. And like I said, you're not going to learn a real strict method for fitting a line like you will in a high school math course. But we're going to talk now about some different strategies, ones that you might have used to draw your line. So it says, consider the following general strategies that students use for drawing a line. Do you think they represent a good strategy for drawing a line that will fit the data? Explain why or why not. Or, explain why or why not, or draw a line for the scatter plot using the strategy that would indicate why it is or why it is not a good strategy. So I think it would be good to pause the video and read through these 4 strategies one by one, and then think about them yourself, maybe jot down some notes, and then come back and we'll discuss them together. And so, so you're going to explain if you think it's a good strategy, and then you could also draw some lines using that strategy to show that maybe why it isn't or why it could be a good strategy. Okay, so go ahead and pause and do that now. Okay, so let's look at these together. It's not Laura, it's Lare, thought she might draw her line using the very first point and the very last point in the scatter plot. So let's try that and see if we think that is a good idea. So I would be connecting, I'd be connecting this point, nope, grab it, close, and connecting it to that point, pretty much. So do we think that's a good strategy? Maybe for this set of data, that could be a good strategy, but there might be scatter plots where if the first point and the last point are not fitting the general trend very well, that method could really backfire on us. Okay, let's look at the next one. Phil wants to be sure that he has the same number of points above and below the line. Okay, so that sounds like it could be a good strategy because we want the line to be kind of in the middle. But if that's your only strategy, what if I just drew this line right here? That has the same number of points above and below. Well, no, it doesn't. 1, 2, 3, 4. I'd have to draw it somewhere else. Maybe maybe right in here. No, right here might give me about the same number of points above and below, but that's definitely not a good line to fit this data. And so that strategy alone could also backfire on a person. But it could be something to keep in mind in general. Sandy thought she might try to get a line that had the most points right on it. Okay, so she wants hers to go right through several points. So here'd be an example of what she would want to do. Not that. Something like that. That has quite a few points that are right on the line, but I could also draw a line maybe here that has quite a few points on it too, which clearly doesn't fit the data. Okay, so that might not be what we want to do. And then the last one is Mary decided to get her line as close to as many of the points as possible. All right, so what does her strategy look like? So that looks like kind of going in between most of the points, something like that. Or, so I kind of want to try to get as many points as close as possible to my line. So that seems like, in general, a good strategy right there. And I could still keep in mind some of the other strategies of, like, you know, points above and below the line. That's kind of a way of making sure I'm showing something that represents most of the data pretty well. Okay, so that's sort of our general method. Question 6 says, based on the strategies discussed in exercise 5, would you change how you drew a line through the points? Or did you basically try to do something similar to that? Okay, so it takes a little bit of practice, but it's, you know, it's kind of just a matter of trying to get as close as you can to most of the data. All right, so let's look at another example, deep water. Okay, so let's read the example together. Does the current in the water go faster or slower when the water is shallow? The data on the depth and speed of the Columbia River at various locations in Washington State listed below can help you think about the answer. So part A says, what can you tell about the relationship between the depth and velocity by looking at the numbers in the table? So I'm going to look here, and it looks like they've listed the data with increasing depth right here. So I can just come over here and look at velocity and see that the velocity starts at 1.55 feet per second. And it looks like in general, the numbers are getting smaller and smaller and smaller. So as the depth increases, the velocity is decreasing. So we could write something to that effect. What can you tell about the relationship as depth increases? The velocity or the current, the velocity of the current, I guess you could say it that way, decreases. Okay, so when you're answering questions about relationship, you want to mention both of the variables. So the two variables here are depth and velocity, and I'm describing the trend that I see in the table. If we were to make a scatter plot of the data, which variable would you put on the horizontal axis and why? So remember, we have this type of thing going on. We've got our x and y, horizontal and vertical. And remember, we said we wanted the thing you choose, or the independent variable is on the horizontal axis, and the dependent variable is on the y-axis. And in terms of this scatter plot issue, the thing I choose goes here, and the thing I'm predicting goes up here. So here's the question. Do I want to measure the depth, choose my depth, and then predict what the velocity will be? or do I want to measure the velocity and predict the depth of the river? Okay, so that would kind of dictate which variable I put on my horizontal axis. This is kind of tricky because we could argue both ways for this, right? But what's easier to measure? I mean, what am I likely to measure, the velocity or the depth? Well, probably the depth. The depth might even be known for various parts of the river and something of record. So probably I would put depth on the horizontal axis here and use depth to predict the velocity or how fast that river's moving. Okay, I don't expect you to fully grasp that idea right now, but as you look at more and more graphs, you'll begin to sort of internalize what goes on the horizontal axis and what goes on the vertical axis. Okay, so here's the scatter plot. It's been done for us, thankfully. Aren't you glad you don't have to put all those dots on in these lessons? So here's our scatter plot, and we want to analyze it. And so we can kind of see the trend that we looked at in the data. We're kind of seeing here, right? It's a negative trend. Choose a data point in the scatter plot and describe what it means in terms of the context. Okay, so just choose any point and tell and describe what it means. So one data point is 9.9 and 59 hundredths. And that means that when the river is 9.9 feet deep, the current is 0.59, and the units on that are feet per second. I ran out of room. Feet per second. So that's what that data point means, and you could have picked any of them. And based on the scatter plot, describe the relationship between velocity and depth. So I could say something like, the deeper the water, the slower the current. As water gets deeper, so here's the deeper the water, the slower the current. How would you explain the relationship between the velocity and the depth of the water? Okay, so this is using the knowledge you have of rivers and water flowing. You might come up with something better than this, but I would just say that when the water's deeper, it's a larger volume of water, so maybe it moves slower for that reason. There might be other reasons, but someone studying this data would be asking themselves that question probably. Okay, so if the river is 2 feet deep at a certain spot, how fast do you think the current would be? Explain your reasoning. So go ahead and pause the video and answer that one. So let's look back at the scatter plot to see what's happening when the river's 2 feet deep. So that would be, there was actually a measurement for 2 feet, and it was 1.11. But this seems to be an outlier. So 1.11, but more in line with the rest of the data would be right up in here, which would be about 1.4 feet per second. So I would choose 1.4 feet per second, but you could have a different estimate for that. Okay, question 8 asks us to consider a couple other questions. If you draw a line to represent the trend in the plot, will it make it easier to predict the velocity of the water if you know the depth? Why or why not? So again, let's look back at our graph and think about what's going on here. So we already looked at this data point and said, well, maybe even though we measured for one depth of 2 and it came down here, it seems more reasonable that it would fit up here. If I'm going to predict, I'm probably going to go with this prediction rather than this one. So in areas where the data is kind of thin, like through here, or a little bit more scattered, like in here, that a line would really help us to make predictions. So I'm not going to write that out, but something to that effect you should write an explanation for. So now we're supposed to draw a line that you think does a reasonable job of modeling the trend on the scatter plot above. Use the line to predict the velocity when the water is 8 feet deep. So let's come back here, and we're going to use some of those same techniques that we talked about in the last example to fit a line to this data. So I'm going to do right about there, and then come over, and I'm to predict for a depth of 8 feet would be right here. And I'm getting about 7/10 of a foot per second. So I'm going to say for a depth of 8 feet, my line predicts 0.7 feet per second. And again, you are going to draw a different line, so you will probably have a slightly different prediction for velocity. About feet per second. Now use the line to predict the velocity for a depth of 8.6 feet. How far off was your prediction from the actual observed velocity for the location that had a depth of 8.6 feet? So let's go back and find, so here is the data point for 8.6, and my line is pretty much right on that point, just a little bit above. So going to the data table, that one was about 0.59 or 0.6, and mine looks to be about 0.65 or something to that effect. How far off was your prediction from the actual? So I'll write my answer. I was almost right on. And I could say my line predicts about not 6.6, we could say 0.65 because just a little bit above it, feet per second, rather than the 0.59 that was measured from the actual observed velocity. Okay, so let's look back at some earlier examples. What do we have? Okay, so one thing that we're seeing again and again is that by making the scatter plot from the table of values, it tells kind of the story of the data much more clearly. We can see things happening and maybe get ideas for further study or things we could examine more closely. And one of the things we see on a scatter plot too is that, you know, this data has values missing right in here. And so a line, by fitting a line to the data, I'm better able to predict in areas like this, or even out here where there are only a few data points. So by considering all the data together, I'm going to get better estimates for different values of the independent variable. In this case, remember, this was size of the house and price. So by drawing the line to best fit all the points, we're going to be able to make better predictions overall. Of course, it's only as good as the data that we started with, but the line gives us more to go on than just a couple points. Okay, so again, reviewing the independent variable, that's the thing that that you choose, that you get to manipulate. I get to choose the size of the house, and my line of my best fit line here is going to predict the price for me. So the price depends on the size of the house here. And let's get the other one. That's the same one. And this one, the velocity of the river depends on the depth. The depth was what we decided would be the independent variable, the thing that we get to choose, and the velocity is what we're predicting from that. Okay, so let's take a quick look at the lesson summary. And the first bullet point on that talks about this dependent independent variable here. And it says the variable that we want to predict is the dependent, and that's going to go on the vertical axis. The independent variable, and they're describing it as the variable not changed by other variables, okay, goes on the horizontal axis. Another way to say independent variable is, in an experiment, it would be the thing you choose, like type of fertilizer or time or something like that. So you'll be exposed more and more to this idea of dependent and independent variables as you go along. When the pattern in a scatter plot is linear, then you can fit a line to describe that linear relationship. And so it describes the relationship between the two variables, and it can be used to make predictions for a given value of the independent variable. And when you're informally fitting a line, you want to find a line for which all the points in the scatter plot tend to be closest. So we talked about those different strategies, but you want to make sure that it's represents the trend in the data, and it does that by trying to be closest to all the points. Okay, so I think you're ready for the problem set on this one, and have a good time with that, and check your, be sure to check your answers carefully and make sure you're using vocabulary about the different trends, the dependent, the independent, linear, nonlinear, and all of that sort of thing. Okay, good luck.